The image arrives too late. The ground is already changed.
A spacecraft circles Mars and tries to catch the moment. It fails, and all it sees is the result. This is happening in orbit. The first frame shows smooth dust, untouched, flat across kilometers of red ground. Nothing crosses it, nothing breaks it. It holds. Then the next pass comes hours later. A dark line cuts through it. Clean, continuous, already finished. No approach, no exit, no contact. Too late. The Mars Reconnaissance Orbiter is watching from hundreds of kilometers above, and every pass is delayed. By the time it looks again, the event is gone. If something moved, it should appear while moving, but it does not. Nothing shows up. The surface changes between looks. The cause never enters the frame. The only thing captured is aftermath. The camera misses the only moment that matters. This is like checking your driveway camera and finding fresh tire tracks with no car ever recorded. The path is real, the action is missing. It should show the motion, it does not. The failure is not the mark, the failure is timing. The system arrives after the surface is already different. Now the image is evidence without a witness, a record with no event. And this is not a single line. The next pass will look again, and it will still be late. Mars does not fail in one place. The camera is late again, and now the map starts breaking. A clean patch appears in one region. Mars Reconnaissance Orbiter comes back from hundreds of kilometers above, and the dust is cut open by a finished track. Too late again. Then the view jumps. Another region, another clean surface, another return pass. The same kind of mark is already there before anyone sees it form. No moving body, no contact, no rescue. The failure has spread from a spot to a pattern. Across wide stretches of Mars, the orbiter keeps arriving after the only moment that matters. If this is rare, then it should stay in one place, but it does not. The map keeps changing. Now the problem is bigger than one strange line. The spacecraft is not watching an event. It is collecting what is left after events have already happened. That matters because maps are supposed to tell a mission what the ground is doing. If the ground changes between looks, the map becomes old the moment it is made. This would break trust fast. It is like checking every security camera in a building and finding every room changed while the cameras were pointed somewhere else. The doors are moved, the chairs are dragged, the tape shows none of it. The blind spot is everywhere. Mars Reconnaissance Orbiter keeps circling. Each pass should narrow the gap. Instead, each pass proves the same thing across another piece of ground. The planet finishes first. Now, one explanation has to survive every region. It has to work on distant slopes, open dust, and tracks that appear complete before the camera returns. Because if it cannot, then the orbiter is not watching Mars change. It is only arriving after Mars is done. The camera misses the slide, the track stops looking impossible, and Mars gives us a way out. Loose dust sits on the surface. A gust hits it, or a slope pulls it down, and the top layer slips. That can make a line. This is happening on Mars, where the air is thin, but the ground is still loose enough to move. Fine dust shifts across exposed terrain. It scrapes away the bright surface and leaves darker material underneath. Now the mark has a body. Not a hidden machine, not a thing crossing the ground, just moving dust leaving a scar after the camera arrives late. The fear drops. Mars Reconnaissance Orbiter returns from above, and the finished track starts to make sense. It missed the motion because the motion was fast, low, and already over. This is like sand sliding down a beach dune after a gust of wind. You miss the slide, but the streak tells you what happened. The ground moved itself. For a moment, the system works again. The before image is clean, the after image is marked. The missing middle is only dust slipping while nobody watched. If dust is moving, then it should follow slopes and disturb the ground around it, but it does not. That is the crack. The explanation now has to carry more weight. It has to explain the line, the timing, the clean edges, and the places where the terrain should guide the slide. Too late still matters. Because the camera did not see the dust move. It only saw the mark after it survived. And now the next image puts that simple answer against the ground itself. The dust answer fails on contact. The track crosses the ground wrong, and the only simple cause starts to collapse. Mars Reconnaissance Orbiter looks down again. A dark line cuts across the terrain, but the surrounding dust stays clean. No spill, no fan, no slide. If loose dust made this, the ground should show the mess. Material should drag, spread, or fall away from the line. But the surface holds. Then the angle changes. The mark runs where sliding dust should not go. It does not pour downhill like sand. It does not scatter across the flat ground like wind pushed it there. The line keeps its shape. Some tracks stretch across terrain large enough to matter for a rover path. If a machine planned from these images, it would be reading a surface that changed before anyone saw the change happen. That can break a mission. The relief from the dust is gone. A natural slide needs gravity, loose material, and disturbed ground around it. This mark gives the result without the damage. If dust formed the track, then it must follow gravity and disturb surroundings, but it does neither. The rule breaks. This is like seeing sand slide uphill with no scattered sand left behind. The streak is there, the physical cause does not survive the image. Too late gets worse now. Delay did not just hide a simple movement. It hid the one moment that could prove whether the explanation was real. And now the camera has only the finished mark, clean edges, wrong direction, and no maker in the frame. The object answer fails too. The camera comes back again, and the cause is still gone. A small rock could have crossed between images. It could have rolled, scraped the dust, and stopped outside the frame. For a moment, that works. Mars Reconnaissance Orbiter checks the same ground again. Before the track, there is no object waiting. After the track, there is no object resting. Nothing arrives, nothing remains. The imaging gap is the trap. It lasts long enough for the surface to change before the next pass can prove what changed it. If something causes the track, then it must appear in at least one frame, but it appears in none. The missing moment owns the story. Now the sequence repeats in the worst possible way. First pass, clean ground. Next pass, finished line. Later pass, still no maker. The movement exists only between looks. That matters for future missions. If a rover depends on these images, it is reacting to a Mars that already moved on without it. The map is late. This is like checking a room over and over and finding the furniture moved every time you blink. You never see the hand. You only see the new arrangement. Mars Reconnaissance Orbiter keeps doing the one thing humans can do from orbit. It returns. It compares. It records. But every return is after. So the first field comes back again. Smooth dust in one image, a dark track in the next. No body before it, no body after it. The ground is always finished changing before anyone can watch it happen.